Alright, so this video is going to discuss inputs and outputs on a FANUC robot. So we have here an LRmate 200 ID robot, and so we can access the I/O. So if you remember, there's actually an I/O button down here on the teach pendant, and so you can press that to get to the I/O screen, or if that button, remember that's actually a programmable button, you can assign a macro to it. So if that doesn't work, you can always go to the menu, and then at the menu you can come down to your I/O and then select your screen. Alright, so it seems like it wasn't updating there, but so if we press the I/O button, right, you can if you press the I/O button here, it'll take you, unless it's been redefined, it'll take you directly to the I/O screen. But if you press menu, you can always come down to the I/O under menu and select that. And then you can select F1 and you can see different choices there. So you have some I/O for your cell interface information. You have some custom I/Os where you can assign I/Os that you use a lot and put them on your custom screen. You can go to digital I/O, analog I/O, group I/O, robot I/O, and then UOP is like your remote PLC or something like that, and SOP is your standard operator panel. And then 9 is an interconnect. So let me start there because I've actually got that set up right now. So if you notice here under the interconnect, I have digital input. DI is digital input, and I have digital input 121 mapped to 104. Now I actually don't actually have digital input wired up to anything, so I'm going to change this to 101. And I've got over here on the robot, I have 4, it's kind of hard to see them, they're way back in the back here. I've got 4 capacitive sensors. And so this very first sensor, you have, as I touch this sensor, you see the light flashing. That is that interconnect. So digital input 101 is triggering the output digital 104. So as soon as you trip this sensor, this light is coming on. So as I touch that sensor, that light comes on. And so that is the interconnect. It makes something happen immediately. It doesn't rely on any teach pendant program. So, but if I disable that, so if I come over here and select F5 and disable that, now we can see that that interconnect is no longer active. So I touch that sensor, but it's not going to trigger it. So that's the interconnect. Okay. If you look at the select, F3, you can see the select. You can have input on the robot. RI stands for robot input, and those are mounted right here on the arm of the robot. So RI means it's mounted on the robot, it's built into the robot. RO is an output built into the robot. So if you look at the second option there, you can have an input activate an output, okay, on the robot. So RI is inputs physically built into the arm of the robot. RO are outputs physically built into the arm of the robot. DI is digital inputs. DO is digital outputs. Okay, and so we can map those in there. So now if we hit F1, we can come over to our digital input. All right, now I'm on this I/O screen. So, you know, I get to this I/O screen by pressing the I/O button or doing the menu going to I/O. All right, and this allows me to activate inputs and outputs. Well, I can't actually activate an input, but I can activate an output manually. So you notice here F3 gives you an input or output. You can change, and so like if you go F1 and you go to analog inputs and outputs, then again, F3 is going to toggle you between the ins and the outs for the analogs. And F1, you know, go back to digital. Now, the LRmates do not have support for analog inputs. They only support digital inputs. All right, so you can have digital inputs and digital outputs, but on an LRmate robot, they do not have analog inputs or analog output support directly on it. You can through Ethernet IP or some other remote I/O feed analog ins and outs through the robot, but they don't have the ability to hook up an analog card, and they don't have one by default. So the LRmates, they only have like about 20, I forget the exact numbers, like 20 or 24 digital inputs and 20 or 24 digital outputs. And those are the only outputs that can be physically wired into the robot. But like I say, you can do through Ethernet IP or some other device net or Modbus sort of thing. You can do other I/O with the LRmate robots. All right, so but here you can see the digital output. Now, if we go to config, this is where you would set, what you do is you map your racks. So you notice here, like LRmates are rack 48. That's a special rack dedicated to the LRmate class of robot. So 48 is the physical inputs. And so you put in like where the slot number they start at, and the numbers that they start at. So you see here that the first digital input of rack 48 is mapped to 101 through 120. And then 89 is, I was just talking about Ethernet IP. 89 is a dedicated rack for Ethernet IP. So if you've got data coming in through Ethernet IP, or you're sending it out through Ethernet IP, that would be through rack 89. And so those are configured. So you can configure those on each of these, you know, and then go back and monitor those inputs and outputs. Now, if I'm under digital outputs now, if we come here to digital output, I can force at any time, whether the teach pendant is on or off. It doesn't matter, you know, whether the robot's running in auto mode or manual mode. I can actually come in here and I can force these inputs. So you see here, I've got these lights here mounted underneath the robot. I can force those on by just coming here at any time and pressing those on or off. Actually, one is a relay, and I don't know if you could hear it click. It's in the back. We can't actually see it at the moment, but it's turning on and off. But if we come down here to like the lights, I can turn on the white light. I can come down here, turn on the green light. I can go back and I can turn off the white light, turn off the green light. Okay, so I can force those on and off. That's what this screen is basically for, is to, number one, do your configure, and number two, to kind of force it. Now, if we go to the input screen, we can see the inputs. So if I, again, remember the item button will get us down to the 100s where these are mapped to. So I'm going to type in 101, hit item, and then 101, I jump down there. So here you can see, not only are these lights lights, but they're also switches. And so if you can see here, I actually have this, if I press the white button, you can see that it's activating, it's turning on and off there on the screen. Okay, and then we have the selector switch. We can turn it right or turn it left and turn those on or off. And we have our capacitive sensors. Okay, so we have those capacitive sensors in there. All right, so so those are physical inputs we can just activate. But we can simulate those. If we're trying to test a program, we may need to come over and simulate this. So we could actually simulate an input, and then we could force it on or off to make it look like the sensor is being tripped by a part coming down the line or something of that matter. All right, so these are just kind of manual adjustments. However, we can program inputs and outputs. So if we come over here, what I've got is a little program. So I have just an ordinary data register, register number 40, which is a counter. And then I have register 41, which is a toggle on. I'm going to toggle this on, and a 42 is toggle off. And so now if you look here, I have digital output. I have digital output here. Is tied to toggle 1, and so if it's a 1, it's going to turn the light on. And then down here, then I'm going to wait for half a second, and then I'm going to turn the amber light. Digital output 104 is the amber light. I'm going to turn it off, which is toggle 2. So toggle 2 is actually off, toggle 1 is on. So I'm going to wait for half a second. So what this is going to do, what this code is doing here, as you look through this code, it's going to turn on the amber and blue light while the white and green are off, and then it's going to flash back. So when I run this program, you can see here it's swapping back and forth between those, and I got the counter, so it just does it 5 times. So it just flashes back and forth 5 times for like half a second. And after 5 seconds, the program's terminated. All right, so that's what this program is doing. It's just terminating. It's just flashing back and forth 5 times each, and then shutting off there. But this is how we can turn digital outputs on in the code. We could also come in here and put in an if statement. And we could come in and say, you know, we could add like some if statement. So like at the very end of this program, then I just forced them to make sure they were all shut off. And if I wanted to, I could come down here at the very end and I could add, let's say I'm going to add an if statement. And I'm going to say if, and I'm going to come down here, instead of doing a register as we did before, I'm going to come say digital in. So I'm going to say if digital in 101, which is my first capacitive sensor, if that is on, okay, so I'm going to say if that is on, I'm going to, let's see, call a program. So let's say I'm going to call a program that says is going to go around my rectangle. So I have this rectangle up on top here. I have a little thing where it maps out the rectangle or the circle or something. So I'm going to call that program. So I'm going to come over here and find this program where it goes around the circle. Okay, so here's a program where I'm pretty sure this one goes around the circle. So when I run this, so I'm going to run this program. And right now I'm not tripping that sensor. So when it gets down there, it shuts the lights off, and then it got down to the end of the program, but the sensor wasn't tripped. The sensor wasn't on. All right, so if I split my screen here, maybe we can see here. We see on this other screen, I'm actually going to turn my input. I'm going to go to my digital inputs. I'm going to hit I/O. I'm going to go to item 101. And we can see there, now that's the output, so I'm going to turn on the input. So we can see the digital input is item 101. All right, so right now the capacitor's off. If I trip the capacitor, we can see it turn on. All right, so now when I'm going to run this program again, and I'm going to trip this sensor. So when I trip the sensor, it'll actually make the robot move now. So it should be calling that. Okay, I guess I needed to be, I need to come back. When you have dual screens like this, the only time you can like test the program, you have to be active in the left window. Okay. Try it one more time. So there I'm flashing. I've got this tripped. So when it gets all the way down to the bottom, you can see now it's going through, and the robot is actually moving through the program. So it called that circle program. It's going around the circle. And when it gets done with the circle, it'll return, and then that'll be the end of the program. Now notice it's already going around the program, so I don't have to keep that sensor tripped anymore. So I let go of the sensor, but it had already started the program. So that's a very important point to note here, right? It's going through, and I haven't tripped it. And so, boom, it got to that last part in the code, and it wasn't tripped. But now, once I'm going to restart it, and I'm going to hold it, and once it starts moving, see, it only checks during that one line of that if statement. That's the only time it's checking the input to see whether it's been toggled on or off. And so any other time, it doesn't matter what that input is doing. The input might be changing or not changing, and it won't run. It's only checking at the if statement. So I'll do this just one more time. We can see while these lights are flashing, I can turn this on. Doesn't matter. It only matters when it gets to the line where it says, hey, is this thing on? That's the only time that matters. All right, so this is just a little demonstration of some inputs and outputs for, we can program those in the code here, as you see. Right, we can say inputs, outputs, we can assign outputs, or we can use inputs and say, hey, if this input is active, go do something. All right, so that's how you use the inputs and outputs inside of an actual program.